This is a question about Equilibria and Kc, but it will require some knowledge of esters from year 13. So there are a few sections to it. I'm going to suggest you work through them, and when you've tried it, review your answers. So here's part A, part B, part C, and finally part D. So if we take a look at part A, where we have a reaction between ethanoic acid and ethane 1,2-diol. So we're making a diester in this case, and we need to draw the structural formula out. Now I'm actually going to do it as a slightly more detailed than structural formula. There are some elements of display formula just so we can see precisely where they've come from, and I'm using colour coding. So I take my diol, which makes up the centre of my diester, and the H is lost from there. And for my two acids, the OH is lost. It's a condensation reaction. We've also made 2H2O, but we're going to end up with a structure that looks like this. Moving on to B, and we have got a table to complete. We have got the initial moles, and we have got one of the equilibrium moles. And to do this, you're really going to need to use the equation as well. So I've added the equation here if needed. Now, what we're then going to do is compare one species to another species, always 1 to 1. If I take a look at the ethanoic acid, it has gone down by 0.29 moles. Now, because it's on a 2 to 2 ratio with water, that means the water has gone up by 0.29, so I have my new value to put in. Now, ethanoic acid reacts with the diol on a 2 to 1 ratio. So if the acid goes down by 0.29, the diol will go down by half that value, 0.145. So what we then do is take that 0.145 away from the 0.205, and we end up with 0.06 equilibrium moles. And finally, we can look at the ester, and I can compare this to the diol because it's a 1 to 1 ratio. If the diol has gone down by 0.145, then the ester has gone up by 0.145, and I've got my 3 marks. Moving on to part C, and we're writing out the expression. Now, this again requires the equation. I'm going to include the equation here again so we can see it, but at the heart of this, you've simply got to remember that Kc is concentration of products over reactants. And the powers come from the balancing of the equation, hence H2O squared from the 2H2O and CH3COOH squared from the 2CH3COOH. But then we are asked why we don't need to know the volume. And we don't need to know the volume because it cancels out. And we can actually see why it cancels out. I've put in, ignoring the actual number of moles, we can put those as 1, but we have got 1 over V times 1 over V squared over 1 over V squared times 1 over V. Now, the 1 over V's cancel out, the 1 over V squared cancel out, and therefore we can ignore volume totally. That will be true for any calculation where the Kc has no units. Moving on to part D, and we have got an equation to do. Now, we are not calculating Kc, so some rearrangement will be needed. A brief overview, a summarised overview of the Kc expression has been included here, and I'm going to rearrange that to make the ethanoic acid the subject of the equation. All I then need to do is substitute the figures in, and once I put those into the calculator, I'll get the value of 0.789.